It is regarded as one of the hardest questions in A levels, but let's dive deep into it. A 25 cubic centimeter sample of 0.1 mole dm per cube hydrochloric acid reacts completely with sodium carbonate. What volume of carbon dioxide gas is produced at RTP? Hmm. So in order to find the solution of this, you have to recognize what is the reactants and the product. The reactant is HCl and sodium carbonate, and the product is carbon dioxide. You have to recall from what you learned in your O level when a metal carbonate reacts with an acid, carbon dioxide, water, and metal salt is produced. Without further ado, what you have to do is first make an equation. Yes, this is the most crucial step in order to solve questions like these. Make an equation. The equation must be that carbonate Na2CO3 will react with HCl in order to form NaCl metal salt plus H2O water plus CO2. But this equation is not balanced because we have two Na here, so we have to add 2, and our chlorine must also be balanced. Then we also have to add 2 here, NaCl. We formed our equation, easy peasy. Then we have to find moles of HCl, our reactant, moles of HCl. The moles of HCl, that's very easy. We have given the, I think, volume, but the volume was given in 25 cubic cube. In order to convert it, we have to divide by 1,000 centimeter so that we can easily convert it into dm per cube. And I'm skipping the step and I'm directly multiplying it with the concentration that was 0.001 mole per dm cube. The mole that I will calculate would be 0.00250 moles of HCl. So now I've also find the moles of HCl. By applying the unitary method, the method, ratio method or unitary method, I can easily find moles of our gas. Okay, I'm finding the moles of CO2. So I can easily convert it into volume, and then I'll further find the gas, the amount of gas that is occupying that container, the gas formed. So by looking at this equation, I'll realize that 2 moles of HCl are required to form 1 mole of carbon dioxide. Keeping that ratio in mind, I'll apply that 2 mole of HCl is required to produce 1 mole of CO2. That means that the moles that we've calculated are 0.250 moles will form 0.001, if I'm correct. Yes, 125 moles of CO2. Nearly 70% of our question is done. And the fourth is our conversion. How much gas is produced? We find out the moles. Now the only thing that remains is the volume. Volume of any gas at RTP is 24 dm cube. So our moles must be multiplied by 24 dm per cube, should be multiplied by 0.00125 moles. The answer that we will have is going to be 0.0300 dm per cube, or we can write it as 30.0 cm per cube. So yes, the final volume of gas that was produced would be 30 cm cube, or that would be 0.00300 dm per cube. So our question was easily solved, and then there are 4